Hello everybody, my name is Dhruv Sandesara and I study at Cinco Ranch High School. I love physics, I spend a lot of time on it and it is my passion. And today I'm shooting a video for optics, which I feel people find difficult to understand and difficult to comprehend. I'm shooting this just with my iPhone and a torchlight beaming in my eyes. So just let's get to the nitty gritty of it. Um, I want to start out by saying in optics, light, according to physicists, has a constant speed in vacuum, and that's the maximum speed it could go at, which is 3 times 10 to the 8 meters per second. But the speed of light does change in different mediums, like glass and all that different matter, which permit light through it and are not opaque. So, and thus the ratio of the speed of light in vacuum over the speed in that medium is what we call as refractive index. And all of the time refractive index is greater than 1 because light travels fastest in vacuum and slower in other mediums. And when one thing that physicists have observed is that light bends towards the normal when it's going from a rarer medium, which is air or vacuum, to a denser medium, for example glass. um, Over here we will see how this happens. We see the light bending towards the normal, and the angle of incidence is I, and the angle of the refracted ray and between the normal is angle R. And also the refractive index of an object is sine of angle I over sine of angle R. And this is also helpful in the cases when you don't know the speed of actual light in that medium, but rather the angle at which it strikes. And you could find this to, you could use this to find refractive index. Um, so now we know that when it goes from air to glass or any other optically dense material, light bends towards the normal, and when it emerges from that or that medium back to the first one, which is the rarer one, it bends away from the normal. And when we use a rectangular block, the incident ray and the emerging ray are parallel but have a distance, which is the lateral displacement, how much the light beam has been not deflected, but shifted from its original path. And this depends on the refractive index, because that's the amount the angle is changing, and also the thickness, because that's how much it would change. Um, when we look at prisms, the emerging surfaces are at an angle, so we can use a prism for making the light deviate a very huge amount, because when it goes from the rarer to denser, it will bend towards the normal, which will be downwards in this case. Let me show you the picture first. This one. So this is the emerging incident ray, the refractor ray, and the emerging ray, and we see at first it goes towards the normal. Over here now you have a different normal, and over here as it goes back into air, it goes away from the normal, and thus we see a major deviation in the path of light. The most of the pictures that we see are about polychromatic light, which shows how white light splits into its original component, the VIBGYOR, violet, indigo, blue, etc. But over here we are gonna examine monochromatic light, which is only one color, so we know it takes one path rather than splitting up into its components. We could take the reason why the polychromatic light emerges is because all the lights have different speeds in that medium, and what we need to keep into account is that the frequency always depends on the source, so it does not change except in more complex situations such as the Doppler effect for light. In this case, no, the frequency does not change. As a light wave slows down, the wavelength of it, the frequency is constant. How long the wave is, the wavelength will change, and if the speed decreases, the wavelength will decrease. So we're done with that. Now I'll try to focus more on the